All right, let's see how you did on this one. Find the domain and range of. What's the parent function here? The parent function? 1 over x, right. And remember, 1 over x has two types of asymptotes, right? One vertical and one horizontal, right? The VA and the HA. So all we got to do is figure out where the vertical asymptote went. The plus 3 in the bottom moves everything what? Left 3. So that's where the new vertical asymptote went. And then the minus 2 moves everything down 2, and that's where the horizontal asymptote went. So it looks like that. We didn't reflect it or anything, right? So it lives in the old quadrants 1 and 3. So it looks something like that. That's all you need to do to sketch your graph. Now, the domain is going to be the set of all x such that x is not what value? -3. We don't touch -3 because there's a vertical asymptote at x equals -3. Okay, so x cannot equal -3 because there's a vertical asymptote at x equals -3. And then for the range, we get the set of all y such that y is not equal to what? -2, and it's because there's a horizontal asymptote at y equals -2. Okay, so we say it doesn't equal -2 because there's a ha at y equals -2. Got it? Easy enough. Okay, so yeah, wait. Questions, comments? Oh, you just need to write. You never seen that before? You've never seen the not equal sign?
I've seen it, but I never know what it means.
An equal sign with a line through it means not equal to.
That makes sense.
Really? I didn't. I thought y'all had that in Algebra 1. This is not equal to. Not equal to. Okay, good. I'm glad you brought that up. Wow, y'all are COVID babies, I guess. Yeah. Yeah, not equal to. Yeah, if you drew like a less than and drew a line through it, guess what that means? Not less than. Right. Yeah, very good. Yeah. Okay, good. Y'all got it. Any other comments or questions on that?
Is there like any other way you can write that, or is that the
Oh, like the domain, if you don't want to say x cannot equal -3, yeah, you can say the domain is x epsilon, negative infinity to -3, union -3 to infinity. That works the same way. It's a lot more writing though, isn't it? Yeah. So whenever it's just an exclusive value that you're not using, it's easier to say x can equal -3, and then by default, all the other ones work. Okay. Yes, for these types of functions, yes. For these parent functions, 1 over x, any transformations, you'll exclude the vertical asymptote for the domain, and you'll exclude the horizontal asymptote for the range every time. Yep, absolutely. Any other comments or questions? All right, we're done. Like in short lines, we'll move on to the notes. We're on example 4, I believe, right? Yeah. What's the domain and range of 1 over x? Ah, look. If it's translated up 2 units and left 8 units. Ah, this is almost easier than our warm-up, right? We don't have an equation. They're telling us what to do. Move it up 2 units. So up 2. I'm just going to move it from 0 up to 2. And left 8, there's -8. And there's our vertical asymptote. Yeah, and then 1 over x, there's no reflections. If there's no negatives anywhere, negative multipliers, whether it's an A or a B, remember, it does the same thing. It looks like that. So you don't even need to know where the graph lives, 1 and 3 or 2 and 4, to answer this question. So what values are excluded from the domain? -8. I'll put x equals -8. And then what value is excluded from the range? 2. Y equals 2. Now notice I didn't put y not equals 2 because it already says excluded. Y equals 2 is excluded. If it asks you for the range, you would say y cannot equal 2. Okay, subtle difference in wording there. And of course, let's just go ahead and fill this out here. There's a horizontal asymptote at y equals 2, and there's a vertical asymptote at x equals -8. Easy, right? Yeah. Now we can write it in set notation. The domain again is going to be the set of all x, such that x is not equal to -8, and the range can be the set of all y such that y is not equal to 2. And as Riley asked in the warm-up, there's another way to do it. It's a little more writing. The domain would be x epsilon, negative infinity to negative 8, step over it, and then cruise to infinity for your x values. And for your y values, you just need to step over 2. So you got y epsilon, negative infinity to 2, step over it, go to infinity. We always step over it with parentheses, remember. Because if you have a bracket there, anytime you have a bracket, that's inclusive. Infinities never get the brackets. And here we don't want to include it on the point we're trying to step over. So those all mean the same thing. Gesundheit. Pretty easy stuff, right? If you just know the characteristics, you know where they go, you can answer the questions. The notation shouldn't be a burden anymore because we've been practicing that all year. All right, number 5, let's see. Using the rational parent function 1 over x, that's our parent function, yeah? Graph the function 2 over x plus 5 by applying the transformations and the reference point. What would the new reference points be? Oh, okay. Well, first of all, let's go ahead and look at g of x. Remember we said that there's a 2 in the top that you can either leave there and call that the a value, or you can pull it out front and it works the same way. But this is your a value, and then the b value is plus 5, and then the d value is minus 3. So let's just go ahead and list what this is going to do first. The 2 is going to be a what? By a factor of 2. Do we really show that? Yeah, we don't really show that. The next thing, the plus 5 is horizontal shift. Which direction? Opposite of what it appears, right? Left 5. Opposite of what it appears. Plus 5, you're like, oh, it's the positive, right? But it's to the left, right? And then down 3, down 3. Okay, so if we're sketching this dude, what's the first thing that we graph when we're sketching these functions? The asymptotes, okay? So left 5, I'm just going to go 1, 2, 3, 4, 5. There's negative 5. Just draw it as a dotted line. That's fine. And then down 3, 1, 2, 3. There's down 3. You draw your horizontal asymptote with dotted or dashed lines. And then the question is, again, does it live in 1 and 3, your new quadrants 1 and 3, formed by the asymptotes, or your new quadrants 2 and 4? Yeah, we never reflected it, did we? There was never a negative multiplier. So it lives there, and it lives there. So again, you always draw your asymptotes first because they're literal guidelines for your graph. All right, now it says to follow the points -1, -1, and 1, 1 to see where they go. Do you remember how to do that? Okay, let's do this. -1 first, 1, goes to blank, comma, blank. All you have to do is what we've been doing all year long. For the -1, which is your x value, you just plug it into the inside of the function, which is plus 5. What does the plus 5 do? Well, if you just add it, you're going to get 4, right? But we have to apply the transformation to it, which is always the opposite. So instead of adding 5, we really need to what? We need to subtract 5, okay? So -1 minus 5 is -6. Yep, -6. Stupid highlighter, I did it again. I did it again. Now I'm trying to erase it and I can't get it. -6. Okay, so it's opposite. We do the opposite for the x. Now, for the y, we do exactly what we were told to do. Now, there's 2 things that we have to do to the y. Does the order matter, Lauren? It does. You pointed that out the other day. We got to do the multiplying before we do the adding and subtracting. So -1 times 2, we do that first, is what? -2. Very good. And then -2 minus 3? -5. Yeah. So for this, we're going to do exactly as it says. And we're going to use PEMDAS. So multiply first and then add last. All right, y'all do the 1, 1. See where it goes. Y'all do 1, 1 by yourself. I'll do it up here, and we'll see if we get the same answers, okay?
so did we just use the negative ones on the first part and multiply it by the
Oh, yeah, I'm sorry. This should be negative 1, negative 1. Yeah, yeah. I'm sorry. I didn't write the negative there. Thank you.
wait, so you always multiply by two?
Well, that's just because this equation has the 2 right there. Yeah, if that had been a 5, we'd multiply by 5. But if there's we always multiply first, whatever that number is, and then we always apply the d value exactly what it says. If that were plus 3 at the end, we'd add 3. Okay, we do exactly what the equation says. So in that case, it's kind of nice to bring the 2 out front because we're mapping where 2 points go. By bringing the 2 out front instead of leaving it there, we can really isolate the inside, which is the x, and then we can isolate the outside. So I would recommend definitely bringing that 2 out front. Definitely bringing the 2 out front. All right, did you get negative 4, negative 1?
Yes.
All right. Masters of your craft, you are. You're getting good. Oh my God, there's still a whole page left. Should we stop now? Y'all ready for the quiz? Tomorrow. Tomorrow. No, we should probably finish. We should probably finish. If negative 4 is an element of the domain, that just means negative 4 is in the domain of the function 1 over x plus 3 minus 2. What is the corresponding element of the range? Be sure to make your answer visible. How are you supposed to do that? If negative 4 is an element of the domain, how do we find its corresponding element of the range? What's that asking us to do? I'm waiting. That means whatever the whoa highlighter. Let's think about what that's asking us to do. First of all, I could sketch this pretty easily just by looking at it. What is the plus 3 going to do? Minus 3. So I come over here to minus 3 and I draw my asymptote, vertical asymptote. The minus 2 moves everything down 2, so I come over here to put my horizontal asymptote. And then the graph's going to live here and here. It says there is an element, call it negative 4, right there. What's its corresponding element in the range? This is really worded for something like complicated wording for something that's actually easy to do. This is just asking us to find the y value there, isn't it? So I'm just plugging and chugging. So it's just f of negative 4. F of negative 4 is 1 over negative 4 plus 3 minus 2, which is 1 over negative 1 minus 2, which is negative 1 minus 2, which is negative 3. It's basically asking us what the ordered pair is. Negative 4, negative 3. Silly wording, right? If 4 is an element of the domain, what is the corresponding element of the range? Plug and chug. All right, now here we are actually adding 3 in the denominator, not subtracting 3 like the previous question, because here we're just evaluating it at an x value. We're not trying to see where that x value went as another x value. We're trying to find the output, not where the x value went. Does that make sense? Okay, good. Hey, speaking of plugging and chugging, we've had questions like example 7 before, and hopefully now we know how to answer them. What is the range of the function restricted over the interval from negative 4 to 0, inclusive with the 4 and not the 0? Okay, let's think about what the parent function 1 over x looks like. That's just the boring one now, where the asymptotes are on the x and y axis. It lives here, and it lives here. And I want to know if I restrict the domain from negative 4, 1, 2, 3, 4, which is right here, to 0 non-inclusive, what y values does this graph take on? Well, it's going to take on these purple y values right here.
Wait, so it's not like positive 4, not the opposite?
No, it just says, hey, let's look at this graph, but let's only look at it for these values of x, from x equals -4 to x equals 0. I only want to look at the graph for those x values. So really, there should be an x epsilon in front of the -4 to 0. We're going to try and make this better this summer so that next year all the x epsilons are in the right spot. So I just need to figure out the y values. I need to figure out what y value this is here so that I can talk about the y values that the graph takes on. Well, I know that as I approach 0, what are my y values doing as I approach 0 from the left? They're getting smaller and smaller and smaller and smaller, approaching what? Not 0, but negative infinity. Would you agree? These are going down, 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 down to negative infinity. So I know the y values are going down to negative infinity. I just need to know the y values where they actually stop at when x is -4. How do I figure out the function value at -4? Plug and chug, right? So let's show that over here. F of -4 is equal to negative or 1 over -4, which is the same as -1 over 4, which is the same as -1/4. The whole fraction's negative. Either the top's negative, the bottom's negative, or the negative's up front. That's the y value there. It equals -1/4. So if I'm trying to write the range on the restricted domain, is it going to be y epsilon? Is it -1/4 to negative infinity? Question mark. Why is that not right? Well, those are the values that I take on, right? Those are the y values. That's why I put y epsilon. Is a is a uh, oh, my hair hurts. What? Yes, why? Does negative infinity go first? It's less than. This is greatest to least. No, boo. You're going to say it's negative infinity up to and including -1/4 with a beefy bracket. That's correct. So really all we did is we graphed it to get an idea what it looks like, and then we just plugged in chug, right? Now normally we would plug in the x value to both of them, right? If you want to figure out what f of 0 is, and you plugged in, you get 1 over 0, and you're like, ay, caramba, that's negative infinity. Okay? You have to know there's a vertical asymptote there. But if this were over any other interval that did not include 0, you would just plug in the left value, your x value on the left, and plug in your x value on the right, and you get the starting and ending y values. And then you get everything in between. Okay? So that's not as bad as somebody made it out to be, not me. Okay? Based on the graph of the parent function 1 over x, which is still sitting right here, we can use that. For what values of x is f of x less than 0? Okay, we need to write this now in words. F of x less than 0 is going to be where the graph, which is f of x, is what? Less than 0? Below. Thank you. Below the what? Below y equals 0. This is a y equals 0, the x-axis, yeah. You just want to translate it into something that you know what you're looking for. If the function is less than 0, that means the function is negative. That means the graph is below the x-axis. For what values of x is this graph below the x-axis? Yeah, well let's redraw it because we're not restricting it anymore. We're using the parent function now. For what values of x is this graph negative? Is it negative at 0? No, it's undefined at 0. Is it negative at 1? No, it's positive at 1. Is it negative at -2? Yes. Is that the only place where it's negative? Nope. In fact, it's negative where? Everywhere to the left of the what? Of the, say it, of the y-axis, which is x equals 0. So everywhere to the left of 0, x equals 0, it's negative. Would you agree? It's yeah, I hope you would agree because it's negative everywhere over here. So you're just going to say for x less than 0. That's your answer. That's all it is. To the left of 0. To the left of x equals 0. To the left of the y-axis. If it wanted to know for what values of x is it greater than 0, that's where is the graph positive, above the x-axis, it would be everywhere to the right of 0. X is greater than 0. Yeah, you flip the inequality. Yeah. So that's always going to be the case if you don't shift it up or down, but you shift it left to right. Like if your vertical asymptote, like let's say your vertical asymptote was, let's say this was g of x, and let's say it was 1 over x plus 2. Now your vertical asymptote is at -2, and it looks like this. For what values of x is g of x less than 0? Well, it's for x less than what? -2, to the left of the vertical asymptote. Yeah. Okay. 2 more. Write the equation of the rational function shown on the graph. Use g of x equals that. Okay, that's the standard form. Now, the first thing that I'm going to take note of is where I have my asymptotes, yeah? Asymptotes. So there's a vertical asymptote at x equals what? Looks like -2. And there's a horizontal asymptote up here at y equals 1. So when I'm filling this out, I think I know the h and the k parts, don't I? So let's fill in what we know. G of x, so far g of x is equal to a times 1 over x plus or minus something plus or minus something. Now, if the vertical asymptote is at -2, in the denominator, should it be x plus 2 or x minus 2? X plus 2. Good. It's the opposite. And if there's a horizontal asymptote at 1, should it be plus 1 or minus 1? Plus 1. Okay. Excellent. Excellent. Yes. Excellent. Now, we still don't know what A is. A is your vertical dilation factor. In order to find A, I need to know at least one point that lives on the graph. At least one. Do I know at least one point that lives on the graph? I know 2. So now we have a decision to make here. You want to use the negative? You want them both negative? Criminy. I was going to go with the other one. But hey, the numbers are smaller in magnitude. Maybe that's why. So remember, when we're using a point for something, we show it. We say at the point -1, -3. That tells me what points you're using. And now we're going to plug it in. So I get g of x is -3. That equals a times 1 over -1 plus 2 plus 1. I just plug it in for x and y, or x and g of x. And now all I got to do is solve for a. All right, so let's do that. I get -3 equals a times, let's see, -1 plus 2 is what? 1, right? And 1 divided by 1 is 1. So I really get -3 equals a plus 1. So if I subtract 1 from both sides, I get a is -4. Yeah. And so just like we did in the previous section where we found k, here we're finding a. We now say so, and we plug it back in to this version right here. So g of x is now equal to -4 times 1 over x plus 2 plus 1. Now the fact that it's negative means that we reflected it across the x-axis, which means that our branches of the hyperbola that we call it, they live in not quadrants 1 and 3. They should live in quadrants 2 and 4 now. Is that where this graph lives? Yeah, we flipped it across the x-axis before we moved it. So yeah, it does live in quadrants 2 and 4, as we suspected. So it's a negative number. Okay, so that wasn't too bad, right? We got the vertical asymptotes first, plugged in as much as we knew, and then we picked one of the 2 points to find A, and then we plugged it back into our template at the top. And now we have a function that just has x and g of x in it. You want to try using the other point to see if we get a different value of A? Do we have time? Sure, let's try it. Let's just try it. Okay, let's just use the other point. Let's say at the point -3, 5. I know it sounds boring. -3, 5. We get 5 equals A times 1 over -3 plus 2 plus 1. And now I solve for A. I sound like Eeyore. Negative 3 plus 2 is negative 1. 1 divided by negative 1 is negative 1. So I get 5 equals negative A plus 1. If I bring the A to this side, it becomes positive A. And if I bring the 5 to this side, it becomes negative 5 plus 1 is negative 4. It's the same number. That's all that we needed to snap Eeyore out of his slump. Just let him do it both ways and realize it's the same. So what?
You do the negative 1 times the A and not the positive 1.
What?
Like, you have to do the negative 1 times the A.
Yeah, because they're multiplied together. The plus 1 is addition, so we got to do multiplication first. So negative 1 times A is negative A. Yeah. We got the same number. Did it matter which point we used ultimately? Nah, as long as you did the math right. It turns out that the one Caden chose was a little bit easier because we ended up with a positive 1 instead of a negative 1. But we got the same answer. Yeah, it's been easy. Okay, 2 steps, 2-step process. Get your vertical asymptotes, your H and K, get your template, and then plug in a point, find A, and then rewrite it. All right. So your final answer is this. Remember, it's not just circling A equals negative 4 and saying you're done. It's rewriting it in the original format. Oh boy. Look at number 10. Rewrite the function. Oh, criminy. Here we go. Rewrite the function 3x minus 4 over x minus 1 into the form A times 1 over x minus h plus k. Can anyone look at g of x and tell me what the parent function is? It's telling us that we can write it in this form, which means that it should be a transformation of that parent function 1 over x, yeah? It's telling us. But what's different about this equation that's different from all the others? There's an x in the top, and all of our other parent functions had just a number in the top. How do we get the x out of the top so that there's only one x? There's only one x, and it's not in the top, it's only in the bottom. Divide. That's fantastic. Were you listening? Did the problem tell you to do that, or did you know to do that? You knew. For the rest of us, if we're stuck, we can lean in very, very closely to that right there, to the vinculum. And if you listen very carefully to what it's saying what? Divide me. Right? That's division. So we got to do division. Now we learned 2 ways to do division last time. Long division or synthetic division. Will synthetic division work here? Because it's faster. Yeah, because we're dividing by a linear factor whose leading coefficient is 1. So let's do synthetic division. We write out the coefficients of the numerator. 3x to the 4th, negative 4. It's just 2 of them. All right? And now what am I going to synthetically divide with if the factor is x minus 1?
1.
Positive 1. Yeah. Bring down the 3, bless you. Multiply, you get 3. Subtract, you get negative 1. That's your remainder. So that means that g of x can be written as, what's the 3? What's the degree on 3? If we started with degree 1, it's just 3. It's your constant. Yeah. So it's 3, and then plus the remainder, negative 1, all over x minus 1. Holy moly smokers. It worked.
That's it?
Well, now we need to put it in standard transformation form. So now I'm going to do 2 things. I'm going to bring the negative 1 out of the numerator and put it out front, and that leaves the positive 1 up there. And then I'm going to put the plus 3, which is in the front, I'm going to put it at the back. See that? Did I write it in that form? Is that the form it wanted? That's the form it wanted. Are we done with that problem? Yeah, we should probably graph it, though, just to go above and beyond. It's always fun to go above and beyond. Where's your vertical asymptote? VA at not just 1, but what equals 1? X equals 1. So let's come over here and put a 1. We'll put a dotted line. And then where's the horizontal asymptote? at y equals 3. Good. So 1, 2, 3. There's 3. We'll draw it right here. And does it live in quadrants 1 and 3 or 2 and 4? 2 and 4. Why, Georgia? It's a reflection. Yep. So it's in the opposite quadrant. So it's going to live here and here. And of course, let's finish off with domain. What's the domain of G? It's the set of all x such that x is not equal to what? 1. And the range is the set of all y's such that y is not equal to what? 3. All right, let's do one last thing here. Let's follow the point -1, -1. Where does the point -1, -1 go? This will be the last thing I have y'all do. You got it? Uh-oh. So close to the finish line. What are we going to do with the x input? Well, we look at the inside, which is 1 over x minus 1. The question is, do we add 1 or subtract 1? Wait, we add, right? We're tracking where an x value goes. So we're moving an x value based upon the transformation. We're not evaluating. We're not plugging in for x. We're not evaluating. We're looking to see where it goes. We know that it's opposite on the inside. So -1 means it's moving right 1. So we need to add 1. What's -1 plus 1? 0, okay? Now, for the y value, we're doing two things. What's the first thing that we need to do? Multiply by -1. Then do what? Add 3. Good. So what's -1 times -1? +1. What's +1 plus 3? +4. Yeah. So this becomes the new y-intercept. The point that was at -1, -1 becomes the new y-intercept. Hot diggity donut. We finished. We have plenty of time. So the rest of today's class you can use to work on the homework assignment for 9.2. And it's due tomorrow at 9 a.m. And what are we doing in class tomorrow? A whole day to work? No, we're quizzing tomorrow, 9.1 and 9.2. You got this stuff. This isn't very difficult. You've had enough experience with the graph that you probably know what it looks like without having to memorize it. Any comments or questions? All right.